Hello everyone, welcome back to the channel. Let's solve Leetcode problem 242, valid anagram. Given two strings, s and t, return true if t is an anagram of s and false otherwise. So like all Leetcode problems, I like to summarize the question or the problem really in my own words or terms. So the input is going to be S and T. The output is going to be true if the two strings are an anagram. False if the two strings are not an anagram. Okay, so what is an anagram? An anagram is going to be two strings that have the same character count. So let's say S is going to be AAB, T is going to be ABA. These words obviously are not the same, but for example, this word, the character A has a count of 2, and the character B has a count of 1. And here, the character A has a count of 2, and B has a count of 1. So this is going to be the example input right above. Just going to put that here. Inputs S and T. Output is going to be true. Once again, the counts of the distinct characters are the same. A is going to be, the count of A is 2, the count of B is 1. The count of A is 2, the count of B is 1. Okay, so now let's talk about the approach we're going to take. And anytime I think in a Leetcode problem, you hear the idea of counting being important, we're most likely going to want to utilize a hash map. So for this problem, we are going to create two hash maps. One is going to be the S count, and the other is going to be the T count, where S count is going to be the key is going to be the character, so character mapped to the count for the S string, and the T count is going to be very similar. The character mapped to the count. So we are going to iterate through, let's do 1, create the two hash maps, iterate through word S and T while doing this, adding the character counts. And then 4, we are going to return the 2 maps being set equivalent to each other. Set to each other. So now let's get into the code. We're going to do S to count, T to count. Now we're going to do for character in S to count C equals 1 plus S to count dot get C 0. So what we're doing here is we're going to use a built-in method get that for each character, we're going to add 1 to either the current count or it's going to be 1 to 0, so it doesn't throw a key error here. So this way, while iterating through, if it's the first character we found, it's going to add 1 to 0. And if that character is already in the hash map, it's going to increment the count by 1. Then now we're going to do the same thing for the next string for character in T to count C equals 1 plus T to count dot get C 0. And then our last step here, we're going to return, basically, we are checking if the hash maps are the exact same. So I think I'm going to run through an example, and that's going to be really clear of what that exactly is checking and what's going on here. So let's use the same example. We're going to do S equals A, B, T equals A, B, A. And then let's do these, create the hash maps. Okay. And we're going to have this character pointer. So initially it's 0 for character in S. A does not exist in the hash map, so we're going to create it. 1. Here, A does exist, so we're going to get the character count. It's going to map to A. We're going to get that 1 value. We're going to increment this 1 value. And then finally, B is going to be set to 0, but then we increment it to go to 1. And then now in this secondary hash map, it's going to work the exact same. So A is going to map to 1, increment at 1. B is going to map to 1, and then 1 more. A is already in the hash map, so we increment it to 2. And then, so now we can see the hash maps are the exact same. So we're returning that these 2 maps are the same thing. So that's why we're going to get this true value. And let's say the hash maps were different. So let's say we had another A here. This would be 3. Obviously, these hash maps are not the same data structure and makeup, so that would return false. Okay. Now let's talk about time and space. So in this question, the time complexity of this algorithm is going to be big O of n n, because we are iterating through, well, we're technically doing two iterations, but as we know with, when we think about time complexity, we minimize the constants to just think about the kind of this n value. So this is going to be a linear time algorithm. And space, this is also going to be big O of n, meaning because we're creating these two hash maps that are going to contain, up to n characters. Because like in the worst case scenario, let's say all the characters were different, it would be A, B, C. So the dictionary length would be n. So when we think of some optimizations here, um, what we could have done was we could have had one for loop here. So, one second. So we could have had one for loop and basically added the characters one by one. And we could have started off with, if the lengths are not the same, you return false, because we know that if the lengths aren't the same of anagram, the counts can't be the same. So then that they're left with two strings of the exact same counts. So we could iterate the um, through one of the strings, and then for one of the strings, we could have added that character count. So that would have been one for loop. In this case, it doesn't make that big example because we just did two for loops, so that two is constant. But that's one sort of optimization we Could have made. It's already more optimized than a sorting approach, which would be maybe sorting this. So putting this into an array, sorting the array, then returning if the two arrays, if the S array and the T array are the same. So that would be n log n. But I think this is a pretty good approach, and I think it's simple to follow and understand. So let's run it to make sure it works. Yep, green there, green there. So thank you for watching, and hope to see you next time.